Hello everyone, I am Om Krishna Gupta. I am assistant professor in electronics and communication engineering in Ajay Kumar Garg Engineering College, Ghaziabad. I am going to take the classes of the subject analog circuits. So, today is the first lecture. This is the first lecture of analog circuits. In this particular class, I am going to discuss the basics of analog circuits, what is analog, what is digital, then about amplifiers, then we will give you the introduction of the complete subject. So, I will start with the introduction, then we will come to the analog versus digital, then after that amplifier. Then after that we will discuss about the complete subject, what we are going to learn in this subject analog circuits. So, starting with the introduction to analog circuits, basically this analog word, it is very much popular. We know that what is analog, we hear it in our daily life. In fact, we all are surrounded with the analog systems, we all are surrounded with the analog system, everything is analog around us, like what I am speaking, it is analog, what you are hearing, that is analog, what we smell, that is analog. So, everything around us is analog. Then the question arises that if everything around us is analog, then as we hear that the world is going to digital, fine. So, if the world is going to digital, then why we need analog, fine. So, it is a very simple, the real world data is analog, fine. So, we have to deal with analog, we cannot escape it, and further, and of course, the computer is your digital, the computer is digital, it will only understand the digital signals, right. So, whatever analog signals we are dealing with, we have to convert this analog signal into digital signal with the help of analog to digital converter, fine. So, this analog, there are various example of analog and digital, like in analog we know that it is a continuous in nature, it is a continuous in nature, and the digital, that is discrete in nature, fine. So, one example of analog system and digital system is like thermometer. We all use this thermometer in our daily life, fine. So, two kinds of thermometer we study in our daily life, we use in our daily life. One is your mercury thermometer, mercury thermometer. So, what happens in mercury thermometer? When we touch this mercury thermometer to the body, then the level of the mercury rises, fine, and we just note down that reading of the temperature. It may be 101 degree Fahrenheit, it may be 102, it may be 103, fine. That is in mercury thermometer. But in digital thermometer, what happens in digital thermometer? In digital thermometer, we get the reading like this: 101, 101.1, 101.2, 101.3 and so on, fine. So, if the body temperature is 101, 101.1, 101.2, anything, but it may happen that the body temperature may be 101.15, 101.15, it may be 101.25. So, with the help of digital thermometer, we cannot measure 101.15, 101.25, right, we cannot measure that. But with the help of mercury thermometer, we can measure 101.15, 101.25, but yes, of course, we need more focus, we need more concentration to read that reading 101.15, 101.25, but yes, with the help of mercury thermometer we can measure 101.15, 101.25, but with the help of digital thermometer what happens, the values are discrete. The digital thermometer will give you the value of 101 or 101.1, 101.2, but not in between 101.1 and 101.2, fine. So, this mercury thermometer is your analog thermometer. This mercury thermometer is the analog thermometer, and this is your digital thermometer. This is one example which I have given, and this thermometer we use in our daily life. Now, coming to next, that is amplifier. So, amplifier, it is a very popular element, very crucial element, very important element of analog circuit. So, as the name suggests, this amplifies the signal. The function of the amplifier is it converts weak signal into a strong signal, weak signal into a strong signal. That is the function of amplifier. So, obviously, the question arises that why we need to convert weak signal into a strong signal. The reason is the sensors which we are using in our daily life, it produces electrical signal, right. Like temperature sensor, it senses the room's temperature and it converts that temperature into some electrical quantity, fine. So, that electrical quantity which we are getting from the sensor, that is very small in magnitude, that may be in millivolt or in microvolt. So, the strength of the signal, it is very small, it is very small. So, it is very difficult to process such a small strength signal. That is why we need to amplify this small signal, that is the first reason, that is why we need amplifier. And another important reason is effect of noise, effect of noise. So, if your signal strength is very less, then it can be easily corrupted, by noise, and if we are designing electronic circuit, there will be noise due to that resistor, transistors, because of the random motion of electron, that voltage is generated, undesired voltage is generated, that is your noise voltage. So, it will be there, it will be there. So, that noise voltage can corrupt your this signal, electrical signal generated by the sensor. So, that is undesired. If this signal is corrupted, that means your information will be lost. That is not acceptable, that is not acceptable. We do not want to lose our signal, to lose our information. So, we need to amplify this small signal generated by the sensor. Once it is amplified, then the effect of noise, it will be very, very less. That is the need of amplifier. And if there is a sensor, and of course, in that case we need amplifier, along with sensor we need amplifier, because the signal generated by the sensor, it is a very small in strength, it can be easily corrupted by noise. So, I am discussing this point, need of amplifier. So, as I have discussed that this amount of noise which is generated in the circuit, it should not corrupt your signal sensed by the sensor, that is very important. So, we need to increase the value of the voltage, and we need to increase the value of the voltage such that your noise, it should not corrupt your information, fine. One example is your microphone, fine, like collar mic, fine. So, what is doing, what I am speaking, that is the sound signal, it creates a pressure, and that sound signal is further converted into electrical signal, but that electrical signal generated by the microphone, it is very small. So, we need a battery operated amplifier, that is your amplifier that amplifies the signal generated by the microphone. That is the example of amplifier, fine. Along with microphone we connect to amplifier, fine. So, that is one example of amplifier, and further with the help of these amplifiers we will study that we can design oscillators, we can design filters, we can design analog to digital and digital to analog converters. So, this is very basic why we need amplifier, but it is not only limited to this, it not only removes the, it not only combat the effect of noise, but also it can be used in various applications in analog design. Now, next question arises, as I said that amplifier, it converts weak signal into a strong signal. So, which parameter is amplified, actually amplified, when we say that amplifier is amplifying the signal? So, there are three parameters, one is voltage, another one is current, and the third one is power, fine. So, which parameter actually the amplifier amplifies, whether it is voltage, current or power? We can understand it with the help of transformer. We all are familiar with the transformer, like step up transformer. In step up transformer, what happens if there are turn ratios, it is if 1:n, right? The turn ratio is 1:n. This is your primary, this one is your secondary, and if we apply a signal Vm cos omega t at the primary, so what will be the voltage appear at the secondary? Since the number of turns at the secondary is n, so the voltage at the secondary it will be n into Vm cos omega t. So, see, your step up transformer, it is amplifying your voltage, it is increasing the level of voltage, but can we say that it is an amplifier? We know that in transformer, if voltage is increased by the factor n, then your current is reduced by the factor n. So, the point is that if we calculate the V dot I product, that is power at the primary, and V dot I product at the secondary, then both the power it will be same, because at the secondary what is happening, if voltage is increasing then current is decreasing, and vice versa also. If we want to increase the current level, just reverse this turn ratio n:1, make it n:1, it will increase the level of current, then but in that case the voltage will be reduced. So, ultimately V dot I product will be constant. If V dot I product is constant, so your power is conserved, your power is not amplifying. So, this transformer, it is not an amplifier, it is not an amplifier, fine. So, the amplifier amplifies the power level should boost up, only then we say that it is an amplifier. If it is only about voltage or current, then your transformer can also, it can increase the level of voltage and current, but it is all about power. Now, next one is, this question arises that this is your amplifier, and if we are giving the power P in to this amplifier and we are getting the power P out from this amplifier. So, as per conservation of energy, your P out cannot be greater than P in. Then how this amplifier boost up the power? Obviously, that conservation of energy is applied everywhere, it is applied here also, fine. So, how this conservation of energy equation is balanced? We know that the amplifier needs some DC battery, that is your suppose that VDD supply voltage is there, DC supply voltage is there. So, this amplifier from where it is getting power? From one source. The one source is your supply voltage. The one source is your supply voltage. The amplifier is getting power from the supply voltage. Another source of power is your input signal source, which we have connected to the amplifier at the input side. Fine. So, if this power is PL, that is the power drawn from the supply, then the total power taken by the amplifier, it will be PL plus P, and of course, it will be equal to your P out plus, obviously some power will be lost inside the amplifier. So, that is your, we can say that, dissipated power. Fine. So, this equation will be balanced. Fine. So, actually your input signal strength is increased, obviously the conservation of energy is applied, and that equation is balanced with the help of this battery. Fine. So, amplifier amplifies the power. Next one is types of elements. This is very basic, you all are familiar with it, and we are going to use these elements to design analog circuits. So, like active elements, we know that which can amplify. For example, your transistor. In transistor, mainly we are going to study BJT and MOSFET, bipolar junction transistor, and MOSFET, that is field effect transistor, metal oxide semiconductor field effect transistor, that is MOSFET. Fine. Passive elements, you know that resistor, inductor, capacitor, it cannot amplify. Passive element cannot amplify the signal. To amplify the signal, we need active element. Linear elements like your resistor is a linear element. Non-linear element like your diode and transistor. Diode and transistors are non-linear element. Fine. So, these are the just basic introduction of active, passive, linear and non-linear. So, just we are going to design the circuit with the help of these elements. Next one is discrete circuit versus integrated circuit. So, discrete circuit, as the name suggests, we require some discrete components like resistor, capacitor, inductor, diode, transistors, and we design that circuit on a breadboard. We design that circuit on breadboard or PCB. That is your discrete circuit, like you do in your laboratory. Fine. If you need to design an integrator or differentiator circuit or any filter, you take some components and you design that circuit on a breadboard and PCB. That is your discrete circuit. Integrated circuit is, that is, in short, it is called IC. We design the circuit on a single chip, that is a silicon wafer, and it is a long process. IC designing is a long process. Fine. So, you have seen that IC in your laboratory, like 741 IC, 555 timer IC, your gate ICs, MUX ICs, etc. Fine. So, in analog circuits, mainly we are going to deal with discrete circuits. Fine. Whatever circuit we are studying in, we are going to learn in analog design, we can implement it on breadboard. Fine. Mainly it is about discrete circuit. Fine. But there are various advantages of integrated circuits, like the area occupied. The area occupied by IC is less, the power consumption of IC is less, and obviously the speed is higher, and the reliability of IC is more. Also, the reliability is another factor, because when we design discrete circuit, there are a lot of soldering, and that soldering can break. So, the reliability can affect in discrete circuit, but ICs are more reliable. But of course, for every small work we cannot go for IC, it is a long process, it may be costly also in some cases, because if the IC is not easily available in the market, then the cost will be high. It is a long process in fact. So, we cannot go for IC for every small application. Sometimes of course this discrete circuit is very helpful, it is very helpful, fine. So, this is about the subject analog circuits. In unit 1 we are going to firstly study diode circuits, then about transistors, then biasing, then small signal analysis of those amplifiers to calculate different parameters like input resistance, output resistance, voltage gain, etc. Then different configurations like in BJT common emitter, common base, common collector. In MOSFET there are 3 configurations: common source, common gate, common drain. So, it is not like that these are the only topics in analog, these are the few topics of analog circuit which I am going to just give you a small overview, fine. In unit 2 we are going to learn frequency response of common emitter and common source amplifier, that is the low frequency response, high frequency response, how the performance of amplifier is affected at low frequency, at high frequency, that we will learn in frequency response. Then different feedback topologies, then we will learn about stability also, like when the circuit is stable, when the circuit is not stable, fine. Then in unit 3 we are going to learn oscillators. Unit 3 is all about oscillators. Oscillator is a device which is used to generate a signal of a particular frequency. You all have seen these oscillators in your laboratory, like function generator. You can generate a sine wave, you can generate a square wave, you can generate triangular wave, right. So, we will learn about oscillators in unit 3. That is also the kind of feedback. We use positive feedback in oscillators, we use negative feedback in amplifiers. So, negative feedback we will study in unit 2 and positive feedback we will study in unit 3. Then in unit 4 we will study a very important component of analog design, that is current mirror, that is very helpful to bias the circuit. It is also used as an active load that helps in increasing the gain also. Then another kind of amplifier, that is your differential amplifier, fine. Then lastly unit 5, in unit 5 another kind of amplifier, that is your operational amplifier. So, it is basically a difference amplifier. So, we will see the beauty of this op amp, in short it is called op amp, that is operational amplifier. It can be used in many applications. We can use this operational amplifier to design various circuits. We can perform various operations, like we can design summer circuit, subtractor circuit, we can design integrator, differentiator, we can design log amplifier, anti-log amplifier, multiplier, divider with the help of operational amplifier. That is a very important element of analog. With the help of this op amp we can design various circuits, and with the help of this op amp we will further design filters. And the filters which we will learn in unit 5, this is active filters. This is active filter, not passive. Active filter means along with passive elements, we will use some active element, that may be transistor. Mostly we use op amp, because operational amplifier IC, one of the IC 741 IC, it is easily available, it is very cheap also. So, with the help of 741 IC we can design active filters, fine. So, all these things we are going to study in the subject analog circuits. Along with it, there are few other topics also that we will learn in upcoming classes. So, this is just the introduction class about what is analog, what is digital, and what is amplifier, what does this amplifier amplifies, why we need amplifier, because amplifier is very important element, and with the help of amplifier you will see that we can design oscillators, we can design filters, right, we can design ADC, DACs, fine. So, there are various applications. So, it is very important to understand the amplifier in analog design. Okay. So, this is all about this class. In the next class, I will discuss about diode circuits. Thank you.